winter break? No?
It's my winter break. You can't have it.
That's good. Yeah. But nothing is good. Yeah. Nothing is good.
Depends on what. Yeah, why? I thought I broke my back while skiing, but it turned out to just be a sprain.
You thought you broke your back?
Oh my gosh, that sounds
I
horrible.
was going 43 miles per hour, and I fell and I skidded through
Whoa.
my face, so I thought I broke my back.
That's pretty gnarly. Yeah.
I was skiing. Oh.
That's still really crazy. Yeah. Anybody else not break their back? That's pretty hardcore. Yeah. You saw the Rory Boy? Yeah. Was it good? Was it nice?
It wasn't that bright, but it was a faint glow.
That's awesome. Wow. How long did it take you guys to trek up there to see this?
Well,
Aurora Borealis.
it took 30 minutes to get up to the observatory.
Uh-huh.
And
That's really cool. Wow. Well, congratulations. That's
Achievement.
Yeah, it's an achievement. Yeah. The pinnacle of human achievement. Actually, nature, right? Anybody else want to share what they did or no?
You want to share? Yeah, what did you do list week?
The first week I think I'll talk more after after class about what I did. But first week was super eventful. Yeah, you already know. So Ruby knows. If you want to know the details, you can ask Ruby. So, and then the second week I got sick, and I just got better today. So it took me a week. Did you get sick too?
Yeah, they thought I had mono.
Oh, really?
Yeah, I didn't, but they thought I did.
Was it worse for you at night? Because I could not stop coughing at night. I was dying.
Everyone gets worse at night.
Stay away from
Stay away from me. Yeah. How dare you? I take that offensively. Okay. But I'm better now. Huh?
My whole family was sick except me, so we couldn't do anything.
Nice. Oh no, not nice for you. I'm sorry about that. You couldn't do anything. My master plan is complete. Okay. Okay. Well, without further ado, I guess we can start classes. Some of you guys that walked in, I don't think I've given you back your exams yet. So Skylar, I think I still have yours right now. Okay. But remind me at the end of class. You guys need to do test corrections for those exams. Dash, I think I have yours as well too. Make sure you pick them up at before you leave. Okay. And you guys should have cheat sheets. I know there's one that's stapled that you don't have. So try to find someone close to you that has a stapled handout. I have this on your. This is on your website or on the website for you to download too and print. You can use these on the exams to whatever end you'd like. Okay, to help you out. All right, so please open up here your handout. So if you don't have this handout, find someone that does have this handout. Okay, because we ran out of copies. Look at this. Look at this definition for congruent triangles. Right, we're gonna look at congruent.
There's 2 stapled papers at the bottom.
Oh, there are. Oh.
You guys just covered there is.
Anybody need any of this? Ruby? That's a hard.
Thank you.
Yes. Anybody else need one? Stapled handout? They didn't get the stapled handout?
Wait,
You
you said it's
young man?
online?
Did you young man need this? Did you young lady need this?
Is there one online?
Yes.
Alright. I'll take it then. Oh,
Yeah, you're just being overly considerate. I know. I see you being super considerate. Okay, read this to yourself. Take a look at it. If you have 2 congruent triangles, what things have to be the same? Everything. So that means all 3 angles and all 3 sides have to be the same, right?
Why else would it be called
So
Why else would it be called congruent?
exactly. Why else would it be called congruent? You're not actually asking me. It's a rhetorical question. Good. Okay. All right. Because that's a deep philosophical question. I'm not ready to answer. Okay. Okay. Then it goes into my first set of notes. So my plan is to hit 6.2, 6-3, 6-4, maybe even a little helping of 6-5. 6-6 is a big, heavy section that I want to dedicate a whole classroom period 2 next week. Okay. I do apologize. I promised you guys I would do a video on 6-2. It never came to be. Okay. So lesson learned. No more promises for Mr. Wade. Okay. A little grim, cynical conclusion there, but just for to your benefit. Okay. Get out a piece of paper. Write down this example. This is the only example I think we're going to need to do for 6-2 for an honors level class. I think you guys can handle the rest of that section pretty easily. And I believe Hassan, you did have a question, so maybe we can address that question before we move on from this section, okay? But we do need to move past 6-2 fairly quickly. I think this is a very easy, can be an easy section, can be. It's not an easy section to begin with. It can be an easy section, okay? Oh yes, okay. Congruent triangles, right? Group triangles. 6-2, corresponding parts of congruent triangles.
There's a triangle right next to the A because it just looks like two mountains.
What?
There's a triangle right next to the A. It's just like two A's.
Oh, I see what you're saying. Yeah. Upon first appearances, do these two triangles look congruent?
Don't check your Mr. Wade.
Yeah.
You're
Sorry about that. Do they look congruent? You're going to be a good friend of mine, yes, because you are very nice of you. Sure, Mr. Wade, your drawing's good. Okay. Truth is, okay, I'm the first to admit they don't really look congruent. But as Marla said, never judge it by its initial cover, I guess.
You heard that?
Just like what it says in the textbook. Don't ever judge it by its cover. Okay. Go by any given statement. So explicitly said, ABC triangle A to B to C is congruent to DFE. And then after you've written this down, you copy down this question, I want you to go up and solve it on the board because we're going to rewrite the solution in a more formalized way after I see that you can just do raw math. I just want to see the raw horsepower math shown on the whiteboard. I just want your brains to start thinking.
Is that 321 or 32.1?
Where?
On the side.
That's 3,281. That's 32.1.
Okay.
Yes, that's 32.1. I'm sorry. This is 32.1. Okay. This is 32.1. This is 38.4. This is 54. So again, after you have finished writing this down, please find a partner. Please find a place on the whiteboard where you can do this. Okay. We need to solve for y and x. Y is x. Where's the bucket of fun? The first Ava. Do you guys need markers or anything?
We stabbed it.
This is going to be your first problem to do, assuming that these two are congruent. I think this is going to be very easy. Hassan, if you don't want to work on this, you can come up to me and ask me the question. I want to see if I can answer it within class time, but if I can't, then you got to wait after class, okay? I'm going to freeze frame this really quick.
We're just finding 8y minus 5 and 2y. It's I'm just kidding. What? Y minus 5 equals 9.
Okay, go ahead. Yeah, I'm confused on this one. 51. Find the measures of where? 41 or 51? 51. Find the measures of 2, 3, and 4.
So then, can't 2 be congruent to 45?
To 45. Yes, because what these dash marks mean is that they are these are an equal measure. Okay. So
I was confused. Like, why are there 3 dash marks?
Yeah, sorry. That indicates that these 3 sides are all congruent. These sides are all congruent as well. So and then you can see angle 4. Where's angle 4 at? Here. Yeah, this is a little bit of a confusing question. These are parallel lines as well, so you can start using your alternate and angle
Okay.
as well. For the rest.
Did you pass back the test?
I did. Give me a little bit of time though, because I need to go through the solutions really quick. I want to get through as many. So for those that came in a little bit later and want to pick up their test, wait till the end of class.
Yeah, it's
okay?
fine.
Okay.
Okay, thank you.
All right, just remind me though. Okay. My brain. Okay, so what did you guys get? You guys got y is equal to 13, and x is equal to 12.4. Yes, I'm just kidding. Yeah, I love your doubt for a second. Like, wait, what? Okay. All right, so we're gonna go through this formally. So let me see if I can kind of move this aside so you guys can see both the solutions and the problem and the initial problem here. So the first step I said was angle F is congruent to angle B. What does Cpctc mean? Cpctc. This should be a no-brainer because it will drive your brain to nothing. Get it? I'm just kidding. Okay. Your brain should kind of fill in some of the words and what the acronym stands for. Yes.
Congruent parts. Oh no.
Congruent
Yeah.
parts of. You could say of.
Congruent parts of corresponding. Triangles. Something. Congruence.
Wait, Sophia, what are you pointing at?
Right there, the title.
So what is it? It's
Corresponding parts of congruent. Mixed it up.
Oh.
So what's the last
C?
no, it'd be a C. Corresponding parts of congruent triangles. What's the last C for though? Sorry. You can fill in words in between. Not converse. Corresponding parts of congruent triangles are congruent. Yes. So does that make sense? Just say it to yourself. Corresponding parts. So if these two triangles are congruent, right? And these two corresponding parts correspond, and these parts are corresponding to each other, angle F and angle B, then should they be congruent? Yes or no? Yeah, they should be. So that's literally what CpCtc means. Corresponding parts of these two congruent triangles should be congruent. Okay. No, that's an actual term. That's literally in your book too. So, but I mean, when you're talking to a professor or someone in the collegiate level, you don't say CpCtc. Easy. Okay. You got to probably say it for the first time, like corresponding parts of was it congruent triangles or congruent or whatever you're talking about. Corresponding parts of congruent anything, polygons or
You
something.
just made that up, or like, is that an actual term?
That's an actual term. That's an actual term, but the acronym you probably don't want to use. Yeah, but the acronym is but most mathematicians in high school, like other students or teachers, they'll know what you're talking about. And then in effect, we got to be super formal. We got to go every formal step. So if these two are congruent, then the measures are equal to each other. I'm sorry about that. Does anybody remember what that should be defined by, or why you can say that? You could say that because these two angles are congruent and they're also equal to each other, then they must be equal to each other, their measures. That is the definition of congruence. Okay? Do we have a measure of angle F? Yeah. And what is that, Indigo? 8y minus 5, and then we could set that up to the measure of angle B, which is 99. Okay? And then what we did there, yes, very good. We substituted in those values from what was given up here. And then your next step here, how did you do that? That was pure magic. That is just addition, the addition property, or you can just say addition property of equality, or just say addition property. So you should have 8y is equal to 104. Oh, sorry, 104. And that step in itself is just called substitution. And then, what do you mean you think it's 13? Who said that? Why do you think it's 13? Divided by 8. So what would we call that property that you just described? Division property of equality. Division property of equality, or just property, and then your final answer should be equal to 13. That is correct. So if you got y is equal to 13, you are correct. Okay. Again, that is a substitution. Why don't you guys take a few minutes to do how you solve for x really quick on your own, and then I'm gonna write it. So I'm gonna write it over here. So at your desk now, okay, think about the work that you just did for that problem for x, and then please write out the formal steps next to it as best you can. Okay. I'm gonna say that there's about 1, 2, 3, 4, 5, 6. There are about 6 steps that you should be able to get from this. I'm gonna freeze frame this really quick. Huh?
Solve X.
Yeah, just like how you solved x up there, but now with more formalized steps. Okay. Welcome back, students, to school. Oh, are you okay? Yeah. Kind of just looked deep into my eyes. Oh, buddy, we're back, aren't we?
I have a question.
Yes, go ahead.
For the triangle, what are the letters to be used? Because if we're doing all the steps.
Oh, did you want to see the triangle? I'm sorry.
Yeah.
Yeah, let's go ahead and do that.
Because if you want all the steps, then the letters.
Sorry about that. Here you guys are. Here's the triangle again. Whoops. This is the solve for x. So set up how you solve for x. Then I'm going to put up my solutions, and you guys can compare your answers. Just use this as a kind of a way to kind of stimulate your brain, tickle your brain a little bit mathematically, so you can kind of get re-engaged back, recalibrated back to class. Okay. Yeah, 5? Escucha, man. How'd you do that? All right, let's see.
Every single step. Did you do every single step? I think. Or did you do it? A lot of people do it in half, 2 steps.
See, I got 18 steps. So
18
I'm
steps.
just kidding. But I did get your brain to.
Probably could you?
If you really extend yourself, okay. If you tried hard enough, you can get 60. There's tons of substitution in this problem.
I have 2 right now, but I'm halfway done. So.
I think I'm on the same route as yourself, Luciana.
Yeah, you're right. Great.
Oops. Okay. And for now, this would probably be the only problem we're really going to go through. And we're going to move to 6-3 after this.
Finger equality.
There's 4 guys.
Mr. Wee, I have a question.
Yes, sir. What's your question?
We have like 30 problems or 20 to 30 problems of just proof for some section.
Do you?
Yeah.
Yeah, I thought I actually lowered down the amount of work that I had from last.
Yeah, and then like for section 6.5, it's like 30 questions and like 20 of them are proofs, and like 10 of them are like.
I do apologize.
On the cup is like literally the
Did
lines
you
are-
make the cover sheet?
I did, yeah, but I made it like 2 years ago, so it's been a while. But like I've modified a little bit here and there, but it's been the same since. There is a
I
lot of
didn't even
questions.
start because it's free and I'm scared of starting.
Yeah, exactly. Same.
Oh, and
Yeah.
also, we don't
I
have
have
notes this month, right?
No notes this month. Yeah.
Oh, no, I have a question for you.
Um,
I think
It
in my
said
packet, I left out a page, and then right here.
Oh,
So,
yeah. If you,
have you already graded them?
yeah, they're already graded, but you can put it in case we missed it. But I'm pretty sure we just skimmed it and we gave you full credit. But
Alright.
but check your PowerSchool
I can
grade.
just show it to you, like,
Yeah, just if you want, you can tear it out. You can put it into a.
Do you think we'll affect my grades on this one page now?
If I caught it.
You caught it?
Yeah, but check your power school grade. So if this is like 95% for your notes, that
Can I
means.
check it right now?
Yeah, that's fine. Thank you for asking. All right, guys, I'm gonna put up the answer for what I got. This is kind of what you should have gotten. You can check your answer right now, and then prepare yourself, okay, for 6-3. Okay, gonna be a hefty one.
Five. What's the hefty one?
6-5 in terms of workload is the hefty one, but 6-3 in terms of the concept for the first time should be kind of scary. Okay, everybody got this? Yes? Yes, Katrina? I'm just kidding. Right. I want to scare you, Katrina. I do not want to scare you. So normally if you did a proof, these proofs can go on forever because you'd have to prove that every single angle and every single side on two triangles is the exact same. That would make a proof very, very lengthy.
Yeah, and like some of the proofs like have like 12, 13 steps.
Yes, that's correct. Well, they still do, even with some of the shortcuts I'm about to show you right now. Because there are mathematicians, or the mathematicians have found out that you do not need to prove that all sides and all angles are congruent on two triangles to prove that they are congruent triangles.
Yeah.
In fact, if you can, right now, on a blank slate of paper or a space on the whiteboard, try drawing a triangle that has 3 equal length sides and prove that they're not congruent. Can you even do that? Is it even possible? Is it impossible? Yeah, try making a triangle right now, if you can, on your paper that has 3 equal length sides. You can use a ruler, you can use a straight edge, 3 equal length sides, and tell me if you can make such a triangle where the angles aren't the same as well.
Can erase part of it.
You can erase part of it. What would be a triangle? It'd just be a V.
Exactly.
Okay, I love it. Ruby is doing her fingers. I like that. Okay. Yeah. Protractor.
Yeah, it's not very effective.
Protractor. Go both of you. It has to be a triangle with 3 completely equal sides.
I love
Equal
that.
sides. Equal sides.
Okay, yeah, I love something.
Okay, so now if I gave you a protractor, go on the whiteboard and do this, please. Please go on the whiteboard. Go on the whiteboard and draw 2 triangles that have 3 completely equal sides to each other. They have to be completely equal sides. And then measure their angles. Just for you, Dr. Dibber.
What are you supposed to do?
Make a triangle that has 3 equal sides to each other. Alright, so 2 triangles that have equal sides to each other. Okay?
Did you want like someone to?
Don't worry about their angles, just draw 2 triangles that have equal measure to each other. You can grab a whiteboard like Natalie's doing, okay? Very intuitive, Natalie. Very quick thinking. Watch your hands, Hassan, okay? All I'm asking is 2 triangles with 3 equal sides. 3 equal sides, like their sides are congruent to the other triangle sides. Does that make sense?
Oh. Excuse me.
Like they don't have to be equilateral triangles. That's not what I'm asking. I'm asking for 2 triangles that have equal sides to each other. Does that make sense? Does that make sense? Like if one triangle was 1 inch, 2 inches, and 3 inches, the other triangle has to be 1 inch, 2 inches.
Oh, okay.
Does that make sense? Does that make sense? Then I'm going to ask you to make another triangle once you're finished with that.
Alright, what's that triangle?
Okay, that triangle has to have one side that is the same, an angle, and another side that is. So let me draw. That one's a little trickier to do. Here. Nope, not an equilateral triangle. I'll give you an example here. Is my screen unfrozen right now?
No.
No, it's not?
It's fine. Let's do isosceles. Oh,
You-
never mind.
You have tricked me. Okay, so I'm doing one that's 2 inches and 1 inch here. And I don't know how many inches. So this is 2 inches. This is 1 inch.
Probably just follow the squares like a line in the graph.
Maybe I could, but I didn't. This is about 2.2. So now I have to make the other triangle the same thing in some way. I could do it. So it's not equilateral. I'm just saying they have to be congruent to each other in the sides. So that's 1.
Oh, to make it the same?
2 inches, and I think this should be about 2.2 as well. Okay. Okay. So you don't have to make 2 equilateral triangles. Just make 2 triangles that are equally measurable on all sides. Okay. And then afterwards, if you're finished, I want you to now measure the angles within that triangle. Are they the same? Measure the angles within the triangle to see if they are the same, roughly about the same. This is about 89 degrees. It's about 89 degrees. Yes.
I think that's as good as it's gonna get. That's really nice.
Where's yours? Nice. Now measure the angles within both those triangles. Did you?
I can do it again.
Just write in the angle measures if you guys can. Okay, that's what I'm asking for. That's what I want you guys to do for me.
How do you use the stroke factor? Or whatever it is. What? How do you use this? You put the line, the angle, and then you find everything.
Oh, the middle.
Oh, no, if you wanna, yeah. And see whichever, the line which you meant, and that line's on.
Oh, 40. Oh, thank you very much.
Okay, and then after you're finished, go ahead and have a seat. And then just ask yourself, did you make 2 congruent triangles? Yes or no? Sophia? Yeah, I guess.
Sure.
Sure.
We can think like that.
I'm going to freeze frame this for 1 second as I write down your next question. Actually, I'm going to freeze frame this here. And then when you guys are finished, go ahead and have a seat.
It was
Just started.
Okay, so okay. Shh. So let's go ahead and look at all your triangles. So when you guys set out to make these triangles, did I tell you to make every single thing congruent? Every little bit congruent?
No.
Did I explicitly tell you to do that?
No.
However, are your triangles completely congruent to each other in almost every way?
I hope so.
You hope so. Okay. So let's just look at the essentials. You need the angles to be about the same. You need the side lengths to be the same. Were both sets the same? The angles and sides? Yes or no? For your triangles. But what did I explicitly ask you to do? Only to construct. I didn't ask you for that. I only asked you for the sides to be the same. Side, side, side. So that should get you, to understand what is on your last cheat sheet for the month. Okay. If you create a triangle, if you set out to make a triangle, you can prove. You only need to prove that 3 of their sides are congruent. Side, side, side. That ensures you that both those triangles that you've proven, where their sides are all congruent to each other, that ensures you that both their angles are also congruent as well. Does that make sense? Okay, so that saves a lot of time because your proofs could probably go twice or 3 times as long if you didn't know that nice little shortcut. You see what I mean? If I were to tell you right now, instead of making you guys just draw a triangle with 3 equal sides, I actually told you to make sure the angles, the angles would all be the same and the sides would be the same. That process would have taken a little bit longer, right? Because you would have been like, oh, we have to make sure the angles are right. You had to make sure the sides are right, right? But if I just told you to make the triangles with 3 equal sides, that saves a lot of time. Okay, so the proofs are going to be the same thing, the same way. The one thing that I didn't tell you to do is make me a triangle where it has a side of equal length, a similar angle, and another side of equal length, and make 2 triangles like that. That's what we call side angle side. If you could prove that 2 triangles, I don't know if you guys can see this, but maybe you should draw on yours as well. If you can prove on 2 triangles that if one pair of sides is the same, an angle right next to it is the same, and then the other side that helps to make that angle with the first initial side I told you to look at, if you have a sandwich where you have a side, an angle, and a side that is congruent to the same kind of, I'm not going to say pair, but like the same 3 things over here, another side, an angle on the side. If all 3 of those things are congruent to those 3 things before that I've mentioned on the previous triangle, then you've also successfully proven that your triangles are congruent. Okay? So there's 2 ways you could, so far, there are 2 ways that you can identify congruent triangles without having to prove every single angle and every single side is the same. If you can prove all their sides are the same, or you can prove this. A side and angle and a side are exactly the same on the other triangle. That would prove that everything else on these 2 triangles are congruent as well. Okay? So I'm going to show you proofs using these 2 shortcuts now. So go ahead and write this down for notes for 6-3. Then we're going to draw, for your example, a straight line. The midpoint, draw the midpoint of that line. Draw points at the end here. So go ahead and take a few minutes to catch up to where I am right now. 6-3, proving triangles congruent. I put a dash, SSS, comma, SAS. Bet you don't know what that stands for. Okay, SAS. SAS. Okay. side angle side, or SAS. I like SAS too, okay? Because this potentially has some good SAS to it, this section. And then we're going to draw, let's see, 2 points that are equidistant from this midpoint here. We're going to draw a line here so it makes it look like a nice V, okay, a symmetrical V. And then these points we're going to connect to the outer points on the initial line that I drew. And we're going to call this G, L, K, H, J. On 6-3, they will indicate to you that you need to start writing flow proofs. Again, I don't want to stray away from our standard 2-column proof, okay? So a flow proof. I'm about to show you what they're asking you to do. Here.
Mr. Lee,
Yes.
in the homework, if it says we have to do a paragraph proof, can
Don't
we?
do it. You can, but you can just do a 2-column proof.
But what if it says a flow proof? The same thing?
Same thing. So this whole book has many different proofs. I don't want you to know that many proofs. I just want you to know how to draw a 2-column proof. One column being statements, the other column being justifications. That's it. The rest of this chapter has a lot of different weird proofs that you don't have to do. You can do it in a standard 2-column proof. The only bad thing is on your solutions manual, it won't have that 2-column proof solution. Right? But you can still use it if you know what you're doing. Okay, so again, in your book, what am I talking about? What is Mr. Wheat yabbering about? I'll go back to the notes in just a second. If you guys can kind of see, it's kind of slanted, but where it says example 1, it says write a flow proof, and then here's what the flow proof looks like. It's like that weird amalgamation of a proof. You do not have to do that, okay? We're going to write all our answers in a 2-column proof. It's going to have the same exact things, the same given statements, the same justifications, right? It's just going to be in your solutions. They're going to give you like a solution that looks like this. Okay. When you write a 2-column proof, your solutions should look still similar to this, but like in a nice 2-column format.
That look easier though.
It does. If you like this, then you can go ahead and do it this way. I'm not going to tell you not to. Okay. But it's up to you. But I'm going to say this: if you don't want to learn that many different proofs, then you can just do the 2-column proof. But
You have the 2-column proof is more like organized in a way where you can.
yeah, and most people in math, when they like using different textbooks, this textbook is the only textbook I've ever seen use a flow proof, paragraph proof or so. I think it's trying to give the students options to writing how to write proofs. They don't have to do 2 columns. But if you do a 2-column, most
T or a J?
what?
It's a J.
That's a J. Shoot the J, right? But most mathematicians across the board will understand a 2-column proof. That's the similar language they use. Okay, so we need to write a proof. Write a proof proving triangle GHL is congruent to triangle KJL. Do you guys want me to do this, or do you guys want to try this?
Do it.
Okay, do it. Okay, I like that. Okay, so here are some given things. GH is congruent to JK. That is what's given to you. GH is congruent to K to J. Notice the way that I kind of go from point to point is very similar to the way I do it on the corresponding triangle. G to H is equal to, or congruent to K to J. You could say loosely that it's GH is congruent to J to K, but I personally like it like if I go from G to H, I kind of want to do it in the same kind of order where I start from the bottom point up to the top, K to J. Okay, just nice little details like that kind of show how much detail you put into your work, right? Some other things. L is the midpoint of GL and LK. Ooh, you've corrected me with good detail. I like that. That was very good. GL is congruent to KL. Or no, it's not congruent. I've only said that is the midpoint. That's it. That's all I've said. Okay, be very careful. So L is the midpoint of GK. That's all that's given to you. Okay. And HL is congruent to JL. So let's write down what I just said for the.
Just put
statement, you're saying? And what is it? Justifications. Statements and justifications. The first thing that we're going to say is given. So first thing that's given to us is GH is congruent to KJ. What else is given to us? Let's summarize what I just talked about. Yes, Luciana.
L is the midpoint of UG.
Notice I did not put any congruent signs on GL or LK yet, or KL. Okay, I just said L is the midpoint of GK. Okay, so that's another. I'm going to put bullet points. You don't have to, but I like putting bullet points on separate statements. These are all given to me. And the last thing is HL is congruent to JL. Don't worry about this table right now, but look what we got. We got two sides that are congruent. To prove that these two triangles are congruent, what else do we need to know? Or yeah, go. Do you want to say? Okay,
A
yeah.
side, another side.
Yeah, just like one more side. So, and then at that point, what can we say? By what theory can we say that these two triangles are then completely congruent to each other?
SSS.
Yeah, by the side congruence theorem. At that point, we could say that these two are congruent. We don't need to go into further detail about the angles. We just know they are.
But could
yeah.
you also do, because you know those two sides are congruent, so the angle in between should be congruent. I mean, the same, right?
Where? Which
Like
angle?
angle H and J, because the two sides, because GH and like the sides are congruent, so the angle should be the same too. The top.
I see what you're saying,
That'd
but
be
let's
side
go
angle.
with that. What is that? Is that technically side angle side though?
I don't know.
It's side angle.
No, the top one.
The top one here.
Yeah, shouldn't they be the same because like on both of them, both their sides are congruent?
What theory tells you that you can do that?
Side angle side.
So what you're describing, I see what you're saying. You're trying to say that if you can prove that these two angles are congruent, you can't say that they are. There's nothing
Even if
to
the sides are like the same.
Yeah, I mean, can't you do these two pens, right? Let's say, shoot, I don't have a good example here. Okay. Give me 1 second, okay? I want to prove this to you. All right, I got it. Mr. Wee's got it, okay? All right. These two pens. You can trust that these are kind of like from the same. Sorry, Mr. Wee's losing his board, okay? They're made from the same manufacturer, right? They look about, right? They're both from Papermate. Do you trust me? Kinda, maybe. Actually, shoot, these are also from the same company, Papermate, as well.
That's Papermate 2.0.
Papermate 2.0, right? Okay, so you could kind of say that these two have the same lengths to each other, right? These two have the same lengths to each other, right? Let's combine and say that these two have, and these two, so far they have corresponding parts that are congruent, right? However, what you're stating has logical sense. Look, if these two sides have equal lengths, right? That must mean the angle in these guys, in this, has to be equal to the angle in these two guys, correct? However, given only what we're given, we only know that these two are the same, right? These two are the same. Watch though. If I do this here, I do this here. Still the same lengths, right? Would you say the angles between these are the same as well?
No.
Okay, so just because, so that's a really good kind of like scenario you just painted. I know you guys are looking at this. You just, it just looks congruent, right? Yeah, Luciana.
Okay, so to add on to what you're saying, if because of what we're given, we can't technically say that because of that they're the same length.
Yeah.
That is, but if we use the midpoint theorem to prove that the last two sides are congruent as well, then you could technically
say that angle is congruent,
Exactly.
right? So right now, only given what we're given, remember, they look so alike. But again, don't let it trick you. It could possibly be like this, where you have two sides. Obviously, this side is the same as this side. This side is the same as this side. But that angle in between could be completely different. The one thing that helps it pull together is probably what you already knew, but you're kind of restraining yourself from saying that because you're just playing. You just want to see another scenario play out. You already know this. I'm not showing you anything new, okay? So hopefully I'm not insulting
It's
you.
kind of like charades.
It's kind of like charades, right? Or maybe
Yeah,
it is.
because like you're given something like it's not like you're seeing. It's like you don't need the picture. That's what they're trying to say. Like just because you're looking at it, it's the same.
Technically, kind of what you're saying is, yeah, you don't need the picture to prove it. You can write these statements and visualize in your head. Yeah.
Yeah. That's
But right now, what Luciana is saying, to pull it together, what makes the angles between these guys the same is that third length. That third length, if you can prove is about the same as the third length on here, then yeah, the angle in here should be the same, right? As will this angle be the same to each other, and these angles will be the same. But the thing that you got to do by the midpoint theorem, if L is the midpoint of G to K, guess what? GL is thereby congruent to who?
LK or KL.
KL. And because that third side, you don't have to draw this down because it looks like I gave this to you in the beginning and I did not. But I'm just saying now we know. That's why I'm doing it in a different colored pen. Now we know if that third side is the same. And like now we can prove, Marwa, that side, those angles are the same. These angles are the same, and these angles are now the same. And how do I know that? I think, Skylar, you were talking about it before. You're mouthing it before. Now we can prove and say that GHL is congruent to KJL because of the side-side-side congruence theorem.
Don't you have to write CP that thing? CPCTC.
Why?
Don't you have to write CPCTC?
That's only if you know those things are congruent.
Like on the side?
So, like, are these two triangles now congruent?
Yeah.
Then if I were to say, okay, if G is, what if
Oh, so you would say like triangle HJL is congruent to JKL. Prove that this side is equal to that side. Then you would say CPC.
what I would mean to say is like, what if this side was 32?
Okay.
This side was X. The angle measures are X to 32, right? And then you try to solve for X, right?
Yeah.
Now that we know these two are congruent, then I could say G is equal to K and set up that equation. The only reason why you could say that is because you knew that these were already congruent.
Yeah.
Then you could set up their angles to be congruent because of the Cpctc.
Okay.
But the first thing you need to establish is that these two are congruent. Okay? Really good question. You guys
But
are.
like for some, for example, this question, I already did this at home. Like in the solution, that has like way more steps.
Well, this is probably the easiest one.
Yeah.
Yeah.
But
Even
like,
if you look at your solutions manual, this should only have like 2 steps.
Yeah,
2 steps.
but for like other ones.
For the other ones, it will get insanely tricky. Okay. Okay. I'm gonna go through one more, and then I'm gonna. Of course I can. Okay. Okay. And then Okay, so your choice. Do you want to try one now to break me talking up here, or do you want me to go through one more and then I give you 2 questions at the end?
Either way, I don't care.
Okay, I like your just like your
Either way,
boldness.
we're doing the same question. So like,
All right, fair enough then. Okay, so 359.
Oh, is it fun? I never tried. Does it hurt when they poke you?
Number 21. Okay. Do you guys see number 21? Go on the whiteboard and solve this right now. Number 21. Yee-haw indeed. Yee-haw indeed.
Write the tables given. Like the triangle. We're doing this one. Yeah. Use purple. Use purple. Okay. Given is what's called line MJ is congruent to.
I'm a little bit scared when I hear close your eyes in my classroom. I don't know what that entails. So, all right, just real quick, close your eyes, okay? Okay.
What happened in high school with you when people told you to close your eyes?
I will never close my eyes again. I'll say that.
Never close your eyes. We'll disappear in 3, 2, 1.
Wherever all my friends go. Not again. I'll go around and help you guys in just a second.
So then you'd say, oh, then those are congruent. Okay,
So then it would be LK
I know.
or KL and JK are congruent.
No, LK. And then that would LK and JK.
Wait, why is it usually like that? I thought you go in alphabetical order.
You can say congruent. Okay, oh, nice. And then this line is basically connected to both the triangles. So I guess with that dance.
Is it okay if I use a reflexive property?
That's exactly what I want you to do. Yes. That's exactly what I want you to do. Very good. Very good. There is a third side that is congruent to each other.
Yeah, but why do you?
But why? Yeah, what is that called when it's sharing the same side?
It's reflexive.
Well,
Is it?
I don't know. It's the one that says it's equal to itself.
Let's look. Wait, why do you use the reflexive property? MKZ to MK.
What do you call it? Because this line is shared by both of them, so it should be the same.
It's like saying
I can say it right now. Maya, why don't you come around and help out the group?
Wait.
I have a question.
It's not on here.
Sorry, it's on that.
Property of
Previous.
Yeah, and then
Oh, okay.
need help. Okay, then
Yeah, the middle.
okay, other people say MK is equal to
We're saying it earlier.
property, and then
Why do you need to know? Okay.
yeah, I know it's like saying the opposite skies.
Okay, write it in the
And then the step after that is then I think after you do the reflexive property, then it's done. MJK is equal to NLK. Yeah, and Which one is it? SSS side.
Just so I know what I'm talking about.
And then the fourth step is
Now we can.
You want the lights off so they can see.
Yeah, that's all. Yeah, sorry about that. One.
I want to do it.
Well, too bad.
Four was.
Oh yeah, it's just right in the triangle.
So four
Why
was
is this schedule?
triangle MJK.
No, I want them to see our very.
Martin Luther
I see. All right. That was profound. I like that.
And then So wait, so is the MK congruent to MK?
If you see it, why does it become yellow?
Yeah. And I have to stay in the same car as you.
we were on the car now. It's like near the shore. It's
Miami. We were camping and I was in the same car. And I would just.
All right. Have a seat if you're all finished here. Very good. Okay, so just to kind of go over what you did. Very nice. Hang in there. Okay. All right. So the three given statements, or the two given statements, I think you guys came up with. Actually, that one's really good up there. I like yours, Sophia. You just, I'm not gonna write it again. I'm not that type of person. You're not gonna make me do it. You pointed it to your given statement. That was very clever. As I'm saying up here, Sophia's, I like hers. She's like, yeah, it's right here. Okay, so just read it, right? I can read it. You can read it too. Okay. So MJ is congruent to ML. K is indeed the midpoint of LJ. Okay. So at this point, you did say, I did say LK is congruent to KJ, as you have up here, because through the midpoint theorem, this guy should be congruent to this guy. The last one is simply this. You guys all just knew that because they shared the same side, it had to be, by default, the same exact measure, correct? It's literally MK exists on one triangle as it does on the other. That is called the reflexive property. Very, very good, okay? It's like reflecting upon itself. And because these three sides are congruent, we had found out that these two triangles are congruent by the SSS, or the side congruence theorem. Again, sorry, so for people at home, I just need to put this back on the projector here so they can see it. So what problem was that? Sorry, that was number 21. Sorry, so this is just for the people at home, so you guys can just hang back. Again, these two are the same. This is in the middle here. This is the midpoint. So LK and KJ are the same, and MK is the same because of the reflexive property. Okay. What? You still have 15 more minutes with me. 15 more minutes with me. I have one more. I have another problem from this section before we move on. Yes, it is. That's okay. It's not okay. You don't understand. Okay. My life right now, Mr. Lee. Is that guy on that side in the page here? Okay, I do apologize. I want to use this online textbook resource, but it's taking forever to load. So I don't think it's... I guess I'll have to use the paper one. It's just...
Wait, where do you find the online textbook?
Oh, I have a copy of the online textbook. You do not.
You can't access it.
Yeah, you guys cannot. Unless I gave you my username and password. Okay, thank you, Ava. All right, I'm glad you...
Is there like a student version?
No, at that point we would have to pay for that version. It costs a little bit of moolah. Some chichiness. The technical term is chichin. All right, I want you guys to try this one here. On the board. On the board again. On the board again. Okay, this one's a little harder to see.
Are we doing that one?
Yes.
The one that you wrote on in your book?
No, I didn't write it.
Sure.
Who could have done that?
I have no idea.
Okay, so right now the question is, do you have the scaffolding for stage lightings? This is the scaffolding right here, including these bars in between, appear to be made up of congruent triangles.
You're gonna get fined.
Not me, not this guy. Okay, so right here we're at X, Z, so it's W, where's X? So let's see. Oh, right here. Wait, why is it W? Yeah, I don't understand here. W, give me 1 second here. I want to look at this. This is not making complete sense here. Okay.
Is it like yes? Wait, that's not.
Right, let me, alright, hold on. Shh. Let me point out a few things. That is point W. This is point X. This is point Z. This is point Y.
Oh, so it's saying
You just wrote your book more.
I did not.
Yes, you
No, I did not. Do you see the color? I don't.
Yeah.
No, just to Miss Susie. Yeah.
Miss Susie? Oh no, please don't. She's a nice. She's very forgiving.
He'll talk to you for hours. I'll tell Susie and Hope on it.
Okay, so if WX is equal to Y. Okay, so and WX is
Let me know if you give up. This is a hard one.
Yeah, I give up.
I don't care. I don't.
Okay, what's the next step?
Okay, so let's see.
I can barely see.
WX. Sorry, so WX right now is congruent to Y to Z. So there are the two triangles. There's this triangle here and this triangle here. WX is congruent to. Oh, sorry. Trying not to move too much. Y to Z. Okay. Also, these two lines are parallel as well. That's all you get. So think about it, all right?
Thanks.
This is a tough one. Yes.
How would you know how to start?
Do you remember anything about parallel lines cut by a transversal?
Yeah.
Okay.
You do have to recall some of your skills for 5.6.
That's fine. It's W.
So if you have your cheat sheets for 5-6, this may help you as well. I'll give you a little incentive. If you do figure this out in the next 5 minutes, I will give you some extra credit.
Wait, what did you say?
I heard you
If you can solve this successfully in the next 5 minutes with your partner, you can get hurt.
We finish this in 5 minutes.
Wait, no, there's not 5 minutes.
Okay, let's do this. You actually have it? Okay.
No, you can help me.
Okay, so
And then
Wait, this is
not confusing. It would just be regular
Everybody in your
triangle.
group is, yeah.
Not this one.
How much extra
I thought we were
I'll give you
against
enough
those. Okay, so
This is a heavy one.
I wish there was just triangles.
wait, so
Will this come to test?
WX.
Maybe. Wow, you were just
It's gonna be on the test.
So if WX is equal
Guys, what's more important? It's gonna be on the test.
this. What does that mean?
Memorize
Okay, so they're parallel.
is everything parallel?
That we are.
These in the line.
Fire! You
Oh
can't
my
ask
gosh,
them for help. You can't just blatantly look at what they're
Hey,
doing.
I asked them
We
for
told
help.
him to go away.
Be gone.
Oh, yeah. Fire.
I don't actually have any
For
idea.
extra credit, you do need to get this original. Okay? You don't want to look at any other people's. What are they doing? It's the only time I'm not allowing you to
Give
look
us
at
an
other
E for effort.
E for effort.
Let's go.
You guys do have all E's. Yeah, E's. E's and E.
Okay, so if they're parallel and they're congruent, where do the sides come in?
So they're parallel. right? And then this is the, so I see a transversal here. What do we know about these two angles?
These two angles are congruent.
From
Well, those
what
two-
theorem though? That's the hard part.
Alternate interior.
Alternate interior angles. That is correct. So now you have a side, an angle, and a side and angle. What else do you need to make this congruent? Another side, right? What other side is congruent? Dash has dashed. Sorry, I had to do it. It presented itself.
Just say that.
Guys, you know how much time?
You have until 10:30. 31. 31.
Wait, so
2 minutes.
I feel like
that's line, you know the
I got
angle,
two
right?
sides, so I
You need that one.
because
How do you prove?
No, we just cleared that one.
And the alternate interior,
It's fine. Okay, we know.
I know, but what angle is it?
Yeah, I never use the, I think it's and then you have.
That's, oh, because this is X, so X,
Oh, line up.
How? No, it would be angle, it would be like angle.
Is
Is it angle? Angle B is congruent to angle.
Yeah.
Why don't they just put the letter
Wait, but
Okay.
but
Fine.
angle Z is this
Yes,
entire.
Yes.
No, it's not because
Guys,
that's
only one
still
minute.
point Z, so that would be.
All right, so I got two people so far.
Because if
You are on the right
that's
track.
point
You
Z,
just have to give me one last
then
thing.
from this
Oh,
line all the way to that line,
Oh.
that entire
But it also
angle is
goes
Z.
to.
So, but then it's cut by that. So these angles and
Okay, so what am I looking at? I'm looking at.
so you have to prove that once it's cut that it's
It's just so many.
Two, yeah, you get three. Dr. Hibbert.
Wait, what did we have
Did they really do it?
We did it.
You get three. Yes, very good. Right. Okay, stop where you are. Have a seat. I'm gonna take a look at your board.
We're not gonna get it. I don't know, man. We actually Whoa.
And I got WZX.
Yeah.
And then XZ.
That's not in anything.
It's too late. The other answer's been locked in. All right. So I will reveal the answers. This was not easy to see. Okay. Yes, it was in your book. Okay, you guys were absolutely keen on that. Okay. The first thing that was given is that W, X, and ZY are given to be the same. Then we also know that these two are parallel to each other, right? That these lines are parallel to each other. Because they are parallel, do you guys see the transversal line that's cutting these two parallel lines? What is the transversal? ZX, if you guys can see that this extends, if this could extend, this would be a full-on transversal cutting these parallel lines. And what we've learned about a transversal cutting two parallel lines is that angles that are on the interior of these parallel lines are congruent. So W, X to Z. This angle right here is congruent to X, Z to Y. And one more thing, you've just learned how to use a reflexive property. This line in itself is congruent. So you have side. So on this triangle, you have a side, an angle, and a side that is congruent to the other triangle by its side, angle, and side. So by the side, angle, side theorem or congruence theorem, sides and angles, yes, these two triangles are congruent. So Petunia, you didn't actually have to list out every single angle and every single side that was congruent to each other. That was beautifully done. Okay. Well, for your statements, if you remember, next to your side, angle, side, you didn't have to do that. And also, Dr. Hibbert actually found another way where you could have done it with AAS, but that's for another section for your next, hopefully, video. Okay, so be on the lookout. If I can get some videos up for tonight for 6-4 and 6-5, I will hopefully have it by tonight. Okay, thank you very much. Okay. All right, guys, pack up. You guys are good to go home. Okay, thank you, guys.
We need our test.
Your test. Stack your chairs. Okay, just your chairs. What's I got my girlfriend's mom's blessing to propose to her. So, okay, thank you. And Ruby, I'm not gonna go through all the details. Ruby can go through the details.
Congratulations.
Thank you guys very much. I appreciate it.
It was a story heard before yesterday, right?
It was a story told before time itself.
Yes.
Yes. It's Mr. Wee.
Okay. So what are you going to propose?
See how it goes. Yeah. Thank you very much. I appreciate it. Oh, thank you so much. I appreciate it. And thank you for being patient with me because I know I teach very slow.